A configuration where the average output voltage is greater than the source voltage, that is V0 is greater than Vs, is called step-up chopper or boost converter. During the turn-on period, when the chopper is closed, the load voltage is equals to 0, but the inductor voltage VL equals to Vs, where the inductor stores energy and the current gradually increases from minimum value to maximum value. During turn-off period, when the chopper is opened, its load voltage is equals to the input source Vs, but the inductor voltage VL equals to 0 and discharges the stored energy, and this voltage add up with the source voltage, which is going to be more than the source voltage. Thereby, the current gradually falls from Imax to I minimum. This is during turn on, so I1. This is during turn off, I2. And then when the chopper again turns on, starts increasing. So according to the nature of the inductor, if it is discharging, the polarities across reverses, so that the instant when it is fully discharged, the polarity across will be reversed completely. This principle can be applied in regenerative braking of a DC motor to transfer the energy from the load to the source. As the load voltage is more than the source voltage, the power may be fed back to the DC source in case of step-up chopper. This results in regenerative braking of a DC motor. This is an equivalent circuit where the load is replaced with E. We have two modes of current. Mode 1, where the current flows through the inductor and through the chopper, it backs to the source voltage Vs. And the current flowing through is I1 during the turn on. The Vs is given by L di1 by dt. Now applying Laplace transforms, you'll get Vs by S equals to L of S, I1 of S minus I1 at 0. Then Vs by S equals to Ls, I1 of S minus L. I1 at initial position is I minimum, so I minimum. I1 of S equals to Vs by L S square plus L I minimum by Ls. Taking inverse Laplace transforms, then I1 of T is given by Vs by L. Inverse Laplace transform of 1 by S is T plus I minimum, as inverse Laplace of transform of 1 by S is constant. Let this be equation A. During this mode of operation, the current must rise and the necessary conditions are di1 by dt greater than 0 and Vs must be greater than 0. Mode 2, where the current flows through inductor, the diode, and through E back to the source Vs as the inductor discharges. For this, Vs equals to L di by dt. Here the current is I2 plus E. Applying Laplace transforms, Vs by S equals to L of S, here I2 of S minus I2 at initial stage plus E by S. Vs minus E by S equals to Ls I2 of S minus L. I2 at initial stage will be Imax. So I maximum, from which I2 of S equals to Vs minus E by L S square minus L by Ls of Imax. Now taking inverse Laplace transforms, we will be getting I2 of T equals to Vs minus E by L. Inverse Laplace transform of 1 by S square is T, and this one came here, so this is plus, so plus Imax. This be equation B. So for the mode 2, the current must fall, and the condition is di2 by dt less than 0 and Vs must be less than E. If this condition is not satisfied, the inductor current would continue to rise and unstables the system. Therefore, the condition for controllable power transfer is Vs must be between 0 and E. So this condition indicates that the source voltage Vs must be less than the value of E to permit transfer of power from fixed source to fixed DC voltage. In electrical braking of a DC motor, where the motor operates as DC generator, whose terminal voltage falls as the machine speed decreases. The chopper permits transfer of power to a fixed DC source to rheostat. When the chopper is turned on, the energy is transferred from the source Vs to the inductor L. If the chopper is turned off, a magnitude of energy stored in the inductor is transferred to the battery E. Without the chopping action, Vs must be greater than E for transferring the power from Vs to E.